Great. Hello, everybody. We've got folks from India, from Mexico. I happen to be in Southeast Alaska. We have someone from Reno, Oaxaca, the Philippines. My goodness, we've got quite the global reach here today. Thank you so much. From Egypt, thanks so much for joining us. For those of you who just signed on, we're going to get started in about 2 minutes. So go ahead and introduce yourself in the chat box to everyone. We are going to kick off the Race to Climate Action webinar, which is sponsored by Enactus and Intuit, and hosted in partnership with Project Drawdown today. So thanks so much for joining us. Hi, everyone. Thanks so much for signing on. We're going to get started in about 1 minute. We are so grateful that you signed on for the Race to Climate Action, Race for Climate Action webinar today. We are here with folks from Enactus, from Intuit, and from Project Drawdown, and we have people from all over the world. We have people from India, from Oaxaca, Mexico, from Reno, Nevada in the United States, the Philippines, Egypt. We have folks from the San Francisco Bay Area in the US, from India, from Springfield, Missouri. We are so glad that you are here. Thanks for taking the time today to think about the race for climate action and how you might be able to be involved. So for those of you just signing on, we'd love to know who you are and where you're signing on from. And we'll get started in just a few seconds. Thanks, everybody. All right, everybody, I'm going to give you a quick overview of the Zoom webinar platform that we're using today. First of all, I'm going to introduce myself. My name is Elizabeth Bagley. I am coming to you from Southeast Alaska in the United States. It's a pleasure to connect with you today. We're using, and I work with Project Drawdown. You'll learn a lot more about us from our speaker today, Dr. Jonathan Foley. I just want to give you a quick overview of what you're seeing in front of you. This is the Zoom webinar platform. Some of you might be really familiar with it, others not so much. Throughout the webinar today, we're going to be asking you to share your questions through the Q&A feature. So if you look at the navigation bar on your screen, you should see something that says Q&A. And that's where we want you to put your questions, please. So go ahead and put any questions you have throughout the talk there. We'll be answering the questions at the end of the talk, but go ahead and store them there so that you've got them for later when we have time to answer questions. Otherwise, we are going to be focusing on Dr. Jonathan Foley, and the rest of us will be off camera, as you all are recognizing that you're off camera as well. But if you need anything, I'll be monitoring the Q&A, and feel free to use that as much as you need to ask any questions. All right, well, welcome everybody. We are so grateful that you are here today for the Race for Climate Action. You're here with some of my colleagues from Enactus. We have Emily and Sheila from Enactus, and from Intuit, we have Sean and Nico and Carla. And Project Drawdown, that's the organization that John and I work for. We were brought in to really be subject matter experts about climate change, and specifically climate solutions. So it is my great pleasure to introduce Dr. Jonathan Foley to all of you. He's our executive director at Project Drawdown. He has decades of experience in climate solutions, and he's going to share those with you today. We know that you'll be inspired. We know that you'll we hope that you will think about ways that you can start putting climate solutions into action in the communities where you live. And we really encourage you to look deeply into the Race for Climate Action and join and become part of that incredible journey that moves all of us forward on our climate solutions journey. So without further ado, I would love to introduce Dr. Jonathan Foley.
Well, thanks, Elizabeth. It's so good to have you all here today as part of the Enactus Race to Climate Action kind of activity. So my name is John Foley, as Elizabeth mentioned. I'm a climate scientist by training, and I was a professor at the University of Wisconsin and the University of Minnesota in the United States for many years, and had the pleasure of working with a lot of college students. So it's really wonderful to be in front of some of you again today. And I'm speaking to you today from Minneapolis in the United States, and it's wonderful to see you from all over the world today. It's so inspiring. So I'm going to share my screen and then share a presentation for a little while about climate solutions. We've all heard a lot about the climate change problem, but we don't really want to have just a problem without solutions. So it's time for us to go to the other side of the street, if you will, and learn about the solutions we need to climate change and how we need to bring our best thinking and our best minds and our best actions to addressing climate change. And we hope that you'll join us to be part of that kind of growing international community. So I'll be sharing my screen and a little presentation here. And then we're going to have, as Elizabeth mentioned, Q&A, questions and answers by kind of through the chat room function later on. So, go ahead and type in your questions or hold them, whatever you think is most comfortable for you, but we'll make sure that we address them. So again, today we're going to be talking about climate action. And I want to give you a little bit about the kind of fundamentals, a little bit of the science, if you will, needed to address climate change. What do we need to know? But before we get to those solutions, I want to just start by kind of getting us to the problem. Why are we here? Why are we so worried about climate change today? Well, if you really think about it, the problem of climate change began a long time ago. Our early ancestors, things that eventually became hominids and then Homo sapiens, started walking this planet about 6 million years ago. And during all of that time, our footprint on the planet was relatively small until maybe the last 2 generations or so. Over a 6 million year period, almost everything changed really just in the last 50 years. And why did that change? Why did our relationship with the planet change so much so quickly? Well, it happened for a lot of reasons, but some of them can be illustrated here. One is just in the last half century or so, we've grown enormously in terms of the number of people on Earth. We've also shifted as a species from being predominantly urban, engaged mostly in agriculture for a living for most of the people on the planet, to now being a predominantly urban species working on many different things. And at the same time, our technology and economic prowess has grown enormously. And in fact, the global economic activity has grown considerably just in the last 50 years as well. So all of these curves are kind of bending upward through what we often call the Great Acceleration, this huge acceleration of human activity that really took place in the last 50 years. Just to put that in perspective, in the last 50 years, the world's population more than doubled, the economy grew more than 5-fold, our demand for food about tripled, our demand for water more than doubled roughly, and the use of fossil fuels almost tripled in the last 50 years. Again, just to put this in perspective, think about it. In the last 50 years, we have changed more than the 6 million years that came before us. So whether we like it or not, we're living at a time that's unlike anything in human history, almost like an inflection point, almost a singularity in the history of our species. And this is now taking us from being a local force, changing the environment around us, which we've been doing for millions of years. But now we're changing entire planetary systems. We're basically disrupting the entire Earth all at once, and in multiple ways. One of the ways we're changing the Earth is, of course, through our use of land, how we're clearing land and ecosystems that live on them, primarily for growing food, but also growing us, our cities and our kind of urban footprint as well. But a lot of the land we use is primarily used to grow food. And you can see that here in a satellite image taken in the mid-1970s. This is a picture of the Bolivian Amazon in South America. And we see a picture in 1975 where we begin to see a dirt road cleared through the rainforest. But if we go back to the early 2000s, we see widespread clearing of large commodity agriculture. Most of these fields you see here are actually growing soybeans as animal feed. And most of the soybeans are actually being shipped, even then, to China to be fed as animal feed, especially for pork production. So globalization is kind of affecting even the last frontiers of rainforest on Earth today. And in the last century or so, we've lost about 30% of the world's tropical forest, primarily in places like the Amazon, West Africa, a little bit in the Congo, and the Indonesian archipelago. And that is obvious. We can see this. We can go out and walk through it. We can see it from satellite. No one's debating this. This is a change that is happening and quite visible to our eyes. We're also changing the nature of water across the Earth's surface due to our increasing activity. Here we see a picture of the Aral Sea in the 1960s and 70s. It looked basically like this. The Aral Sea was once one of the greatest inland seas in the world, and it was fed by two rivers you see to the east that drained water from the mountains far to the east from snowmelt, and then formed this large inland sea in a depression largely surrounded by desert. But the Soviet Union back then dammed up those rivers and started to use that water to irrigate the deserts of Kazakhstan to grow cotton. And as part of this large kind of construction and dam project, we see this, that basically the water supply to the Aral Sea was shut off and the sea has largely disappeared. We have essentially erased one of the great inland features of Earth's surface. And now all of the globes we have on the classrooms all over the world now need to be updated to erase the sea from existence. And this is not unique to Kazakhstan or the former Soviet Union. This is happening all over the world. In the United States, we see this in the Colorado River, for example, or in parts of California. We see it in the Lake Chad Basin. We see it in Iran. We see it in other parts of the Middle East. We see it in Australia, and so on and so on. That we humans are manipulating water and using more than nature can sometimes replenish, leaving us with collapsed water resources all over the world. Again, another very visible change. I started with these two kind of visible changes to the Earth, both in land and in water, because now I want to switch to the less visible change that we're causing as well. This is the changes to our climate. You've all heard this before. I don't need to go into the great detail here, but we humans are adding gases to the atmosphere above and beyond what nature would have had there in the first place. Largely gases like carbon dioxide and methane and a few others that have an ability to trap heat in the Earth's atmosphere. That is solar radiation. The sun's heat basically comes through those gases unencumbered, warming the surface of the Earth. The surface, though, emits infrared radiation back to outer space, and these molecules absorb infrared radiation and re-emit it to the surface, keeping more radiation and heat, if you will, in the lower atmosphere, making it warmer. As we increase the level of these gases, so do the temperature increases go as well. And we've known about this a very long time. In fact, it's been this science of the greenhouse effect has been known since the 19th century. And when I was a student, I was told that this kind of curve, that when we first understood that increasing the level of greenhouse gases like carbon dioxide would also lead to an increase in temperature, which is exactly what's happened, by the way. We see that the CO2 levels of the atmosphere have increased by about 50%, and already the temperature of the planet is increased by about 1 degree Celsius. I want to stop here and note something, though. When I was a student, I was always taught that this was discovered by Tyndall, a British scientist, and then later confirmed by Arrhenius, a Swedish scientist in the late 1800s. And I recently learned that, in fact, both of those things were wrong. It was actually an American woman named Eunice Foote who first published this before any man in the 1850s. And she wrote a paper about how increasing CO2 would cause warming of our atmosphere. And that was largely forgotten and ignored, probably because of just her role as a woman doing science in the 19th century. Well, we need to do better and recognize the accomplishments of women scientists. So I always want to stop here and mention the name of Eunice Foote, who is also not only a great scientist, she was a leader of the women's suffrage movement in North America as well, and helped get women the vote later in the United States. So this is somebody we should all know and should be in every textbook, but sadly still isn't today. So that's kind of the basics of climate change. If we add gases to the atmosphere, it'll warm the planet. And we've known this for over 100 and something, maybe 170 years now. This is an incredible challenge. It's not just, a little bit of warming, who cares? It's not like, why this isn't irrelevant. It's very relevant. It's an incredibly important challenge because as climate changes, even a little bit, it disrupts so many other things that are connected to our climate, whether it's our food supply, our water, our air quality, our health, but also more fundamental things to most people like our economy, jobs, our security, our health, the fate of our children. All of those things are touched by climate change. And so if we want to have a healthy future, we need to ensure that climate change is addressed. Otherwise, things will get very, very challenging very quickly. So you have heard a little bit of this before, I'm sure. But one of the things I need to tell you right now, it is not hopeless to address climate change. If anybody tells you it's too late to address climate change, they're wrong. It's never too late. We can stop climate change a little bit. It's already happened, but we can stop it from getting worse. And so don't lose hope. Let's roll up our sleeves and get to action and make sure that we can make climate change stop today so we ensure a better future. And also, don't believe anybody who tells you what they think the future is going to be. The future is yet to be built. We haven't written the script yet. You and I, especially you of younger generations, will be building this future. So you have a choice to make. Do you want to have a future that you want, or do you want a future you don't want? Pick one and work for it. I believe that we can still build a future we want where everyone can thrive together along with nature, but we have to work for it and we have to first make that choice. And again, addressing climate change will not be the only issue we need to address to build a better future, but it's one of the fundamental ones. If we don't address climate change, all the other things we care about around equity, justice, prosperity, resilience, respect of each other and all human life, all of those things are going to be harder in a world where climate change is careening out of control. So addressing climate change may not seem like a humanitarian issue, but it is. If we don't address it, we will have a poorer future for so many. So that's what we're going to talk about today. What are the solutions to climate change? Elizabeth and I both work for an organization called Project DRAWDOWN, which is a nonprofit where largely kind of academics and science communicators and educators who are trying to be a resource to the world to learn more about the science behind climate solutions and then how we can enact them. We use the word drawdown very specifically to talk about the future. What does drawdown mean though? Drawdown refers to this. As we've seen, the level of greenhouse gases in the atmosphere has been building up, and as it gets higher, so does the temperature of the planet gets higher. And as we've gone through the last 100 and something years, we've seen the levels of greenhouse gases rise to where it is today, to that curve right in front of you. The question is, what will happen in the future? Will we continue to raise the level of greenhouse gases higher and higher, warming the planet even more? Or do we make another choice? Do we choose to kind of bend the curve, if you will, turning those greenhouse gas levels back down again? We hear this expression a lot in around COVID-19 today in the pandemic about bending the curve. If we don't address the pandemic, more people get sick. But if we do address the pandemic, we bend the curve back down and fewer people get sick. Same thing with climate change. We have one trajectory that's bad and another where we put a lot of work into it to bend our civilization's curve, if you will, back to a safer place. Well, the moment that we start to bend that curve and we hit that kind of inflection point, that blue dot, that is the moment of drawdown. Drawdown is a moment in time in the future that we're going to work towards when the levels of greenhouse gases stop climbing and they level off and then they start to steadily decline. That's the moment we can stop future climate change. And the minute we bend that curve is the sooner we get to that, the better, because that's when we can stop climate change from getting a lot worse. And the mission of our organization is to help the world get there as quickly, but also as safely and equitably as possible. So how do we do it? How do we achieve drawdown? How do we get to that moment where we stop climate change? Well, again, the problem of climate change is caused by greenhouse gases. You've heard about a couple already, like carbon dioxide. You may have heard of another one called methane, and there's a third one that a lot of people don't know about called nitrous oxide. And there are hundreds and hundreds of smaller gases, the most important of which are called fluorinated gases, which are also quite crucial, and I'll mention those a little bit later. But these three gases we've been measuring for a long time, and we know that all three have been increasing kind of similarly, even though they all come from very different sources, very different things in human activity release these gases. but they all have this same kind of shape curve where they all go up steeply, especially starting in the mid 20th century, I should say. So where do these gases come from? This is the chemistry part of it, but where do they come from in terms of their origin story? Which gases come from what activities that we do as humans? Well, here's the basic layout. You've probably heard a lot about this part of the story, that carbon dioxide, one of the most important greenhouse gases, really the dominant one in many ways, largely comes, but not exclusively, from burning fossil fuels. About 62% of today's climate change is being caused by us burning fossil fuels, that is coal, oil, natural gas, and a few others. When we burn those, releasing carbon dioxide to the atmosphere, it's building up, causing more climate change. That's not the entire story. It's about 62% of the story, but a very, very big part of the whole thing. But it turns out that carbon dioxide is also released chemically, not by combustion burning fuel, but just from the simple chemistry of some of our industrial processes, especially when we make cement and concrete. Chemically, when cement is curing, it releases carbon dioxide out of the mixture. That's also very important. It's kind of funny, if cement were its own country, it would probably be the third or fourth largest emitter in the world after China and the United States, basically. So that's pretty interesting. We also have a lot of carbon dioxide coming from land use, primarily deforestation. When we burn trees, like in the Amazon or in Indonesia, it's not that different than burning coal. They're both made out of carbon. Some carbon is dead and basically geological. Other carbon is alive and biological. But chemistry doesn't matter. You burn carbon, you still make CO2, regardless of the source of that carbon. So burning down forest and clearing forest, even tilling soils, can release carbon dioxide into the atmosphere, just alongside the CO2 from fossil fuels and other industries. Then we have the other gases I mentioned, methane. Methane comes from a variety of different sources, one of which is industrial. Methane is also natural gas. It's the same thing. We use just two different names for the same thing. And so when we mine natural gas, also coal mines can sometimes leak methane into the atmosphere. Also, natural gas pipelines are often very leaky, especially in some countries, in the former Soviet Union, for example. They can leak very large plumes of methane out of leaky natural gas infrastructure and get into the atmosphere as well. But methane is also caused by agriculture and human activities related to livestock and rice fields and even landfills, where you have anaerobic, basically, breakdown of carbon happening, whether it's in the ruminant digestive system of cattle and sheep, or in anaerobic rice fields, that is, places devoid of oxygen. So it turns out about 2/3 of the methane that being emitted by people today is happening from agriculture, about 1/3 from making natural gas. And agriculture is mostly cattle, a little bit from rice fields, and we can throw in landfills as well. By the way, a lot of people joke about cattle and how cattle, excuse me for being a little crude here, but how cattle burp methane and they fart methane. Well, actually what they do is they burp methane. Cattle don't fart methane at all, really. They burp methane because the chambers in their stomach are digesting different kinds of grasses and other very hard to digest materials using rumen. That's why they're called ruminants, and they burp methane out of the front end of the animal. So hopefully something you learned today. The last gases I'm going to talk about today include nitrous oxide, N2O, which mostly comes from agriculture, primarily when we overuse fertilizers or manure on agricultural fields. Things that are rich in nitrogen, like chemical fertilizers and manure, under certain conditions, if we apply too much, especially when it's cold and wet, will chemically release N2O, or nitrous oxide, into the atmosphere, another major greenhouse gas. And finally, this is a gas family called F gases, or fluorinated gases, that I promised to mention before. These include the old chlorofluorocarbons we used to use as propellants and refrigerants that caused harm to the ozone layer and been largely phased out. But they were replaced with something called hydrofluorocarbons and other chemicals that are ozone friendly, but they turn out to still be potent greenhouse gases. While that only looks like 2% right now, that number is poised to grow dramatically as many people around the world are buying their very first air conditioning units or refrigerators and freezers, as billions of people are now entering a global middle class and able to purchase these things. If we don't do something about those chemicals in refrigerants, that number could grow dramatically in the coming decades, and that's why we pay a lot of attention to that. So we can see here, this is kind of where greenhouse chemistry comes from, where these greenhouse gases originate from. Some of it's related to energy in the kind of orange color. Some are due to exotic materials like fluorinated gases, concrete, cements, things like that. And then the green areas are related to land use and agriculture. So those are the big things that cause climate change: using energy, growing food, and exotic materials. That's pretty interesting. But it's not the whole story, because the atmosphere is a dynamic system. There are things going into the atmosphere, and there are things going out of the atmosphere too. It's all happening at the same time. I sometimes like to think of the atmosphere, it sounds weird, but to think of the atmosphere as like a giant bathtub in the sky, where you can fill it with the faucet, but you can remove water from the bathtub by the drain at the bottom of the tub. So we have things going into and out of the bathtub, just like we do the atmosphere. The things that go into the atmosphere that we're causing are these sources of greenhouse gases. I showed them to you before by the kind of major chemical type and the kind of large origin story of those gases. Here, and from now on, I'm going to talk about it in terms of the economic areas of activity, kind of what do we do and what do we get for it. And we'll go through this later, but you see electricity, food, industry, transportation, buildings, and energy-related emissions. This all adds up to 100% of our emissions all going into the atmosphere. This is the stuff we're putting into the sky. But again, Earth is a living place, and these chemicals that we're adding to the sky can also be removed, and some of them are being removed today by nature itself, primarily on land thanks to our forest. Carbon dioxide in particular is being absorbed by a lot of our forest on Earth today, and about 24% of the total greenhouse gas emissions we put in the sky are automatically removed within about a year by growing forest all over the planet. Oceans are also responsible for some removal of carbon dioxide, and that's about 17% of the total greenhouse gas budget. And that leaves roughly 59% of the greenhouse gases in the atmosphere building up year over year, making it warmer. This picture, we call it the rainbow diagram in our organization sometimes. This is probably the most important picture you'll ever see around climate change, because it summarizes the human activities on the left, the 5 or 6 things that we do that cause greenhouse gas emissions. And then we have nature's ability to remove some of them, about 40% are removed by nature, leaving roughly 60% behind as the accumulating problem building up, warming the Earth's atmosphere. So to achieve drawdown, for us to stop climate change, we can work both sides of this equation. And this is what we need to do. Today, this is the picture. We're emitting more gases into the atmosphere than nature can absorb. And so it's building up over time. And so greenhouse gas levels are increasing. But what if we changed our fate? What if we started to help bring those sources of greenhouse gases, those emissions, what if we started to bring them down to zero? What if we could find new ways to make electricity, food, and new ways of doing transportation, new ways of managing buildings that didn't emit greenhouse gases? And at the same time, what if we protected nature, especially our forests and our oceans, so they could continue to remove some of that stuff from the atmosphere? If we could do that, we stop the pollution from its source and we help nature at the same time. We attack both sides of this equation, and that's when we bend the curve and reach drawdown and stop climate change, bringing greenhouse gas levels back to normal. So that's what we're going to do. We're going to look at the solutions on the left-hand side of the equation, how we bring the sources of greenhouse gases to zero, and we'll look at those on the right about how we can work with nature to remove some greenhouse gases, and we'll look at a few other tricks we might have as well. So at Drawdown, we actually look at dozens and dozens of solutions around the world in these big areas. Again, the first principle we should always follow is stop the emissions of pollution from the beginning. Again, remember that bathtub I told you about? Imagine a bathtub in your home is filling up and the water's overflowing, damaging your home. The first thing you want to do is turn off the faucet. You can go get another mop and you can try to clean up that water, but if you don't turn off the faucet, you're really never going to get anywhere. So stopping the emissions when they begin is the important first place to begin. So this is the left-hand side of the equation where we see all these different sources of greenhouse gases. Let's walk through them one by one though. About a quarter of climate change globally, again, these numbers vary a lot from country to country, even province to province, but globally, in the whole atmosphere, about a quarter of climate change is caused by making electricity, burning coal and natural gas primarily to make electrical current used in a variety of different applications around the world. Another quarter, roughly, of climate change is caused, surprisingly to some people, by the food system. That is, growing food, our agricultural practices, and the related land use practices. Those collectively emit a lot of greenhouse gases. And it's interesting that electricity and food are about equal, and together they cause about half of climate change right there, making food and making electricity. Then we have all other industrial emissions. We'll go into that in some detail later. We have transport, moving things around, burning fossil fuels. We also have buildings. These are the emissions directly from buildings themselves. We account for the electricity used in buildings over in the electricity generation part of the diagram because they're emitted at the power plant, not at the building. The buildings also directly emit their own greenhouse gases within the building themselves from furnaces, boilers, hot water heaters, and so on. And then we have the remaining 10% is mostly in the energy industry itself, whether it's what we call fugitive emissions or converting crude oil into its subsequent uses like petroleum products like kerosene, diesel fuel, and so on. But it's interesting, it's very easy to remember the top 5 problems around climate change are about 90% of the problem are electricity, food, industry, transport, and buildings. Those 5 things cause 90% of the problem of climate change. And if we can solve those, we've got a lot of the problems solved. Let's walk through them a little bit one at a time. So electricity, about a quarter of the climate change problem right here. And it turns out electricity production is half of the story here. Again, burning coal and natural gas to make electricity. If we use something else to make electricity, like solar panels, windmills, and so on, we can alleviate a lot of that problem. But we also can look at not only how electricity is produced, but how is it used? It turns out that we use most of our electricity in buildings, mostly residential buildings, but also some commercial, in industry, and then in other parts of the economy. So it turns out to address electricity, one of the first things we can do today, right now, even if we still burn some coal and some natural gas for a while, we can at least be far more efficient with the use of electricity. Let's stop wasting electricity when we don't need to. So we can first make it more efficient, using less, thereby emitting fewer greenhouse gases. And here's a list of different solutions we've looked at in energy efficiency related to the electricity sector. Things like thermostats, building automation, better lighting, better building envelopes, including glass, roofs, and so on. Better heating systems like heat pumps, solar, hot water. Why do we need, natural gas to make hot water? The sun can do it. Water fixtures and so on. These are all very good steps that are almost immediately available today and often pay for themselves within a year or two after installation. Very, very good place to start. At the same time, as we make things more efficient, we can also shift the way we make the remaining electricity away from coal especially, and also natural gas towards no carbon or at least low carbon technologies like solar, wind, hydro and ocean power, geothermal, biomass, nuclear, other ways of capturing energy from waste streams, and so on. So we've looked at these solutions all together, and this diagram, like a bubble diagram we call it, summarizes the potential sizes of these solutions over the next 30 years or so. The size of the circle is meant to be proportional to the size of the solution that these could put on the table. So we see a whole bunch of solutions around energy efficiency on the right, and some very large solutions around shifting production away from coal and gas to wind, solar, and other things on the left. So we can both be more efficient and shift the mode of production. Very, very important. And that pattern of increasing efficiency and changing the way we make something is going to show up again many, many times. But that's the electricity story. We can go through the others a little more quickly. Food and agriculture is also a major source of greenhouse gases, almost tied with electricity, about 24%. And it's causing a lot of emissions from various different sources. For example, deforestation is the single biggest part of that, clearing rainforests to make new agricultural lands, especially for cattle, soybeans as animal feed, palm oil, and some timber products. Those are really important. And meat and palm oil are the kind of primary drivers of this right now. We also have methane emissions, largely from cattle and sheep, but also a little bit from rice fields. Again, the story of meat shows up here a lot. Cattle, both as a driver of deforestation, but also the biggest driver of methane emissions is really important here too. Third is nitrous oxide emitted from overusing fertilizers, whether they're chemical fertilizers or manures. Just using too much can also release nitrous oxide. Everything else in the food systems are remaining 5% of that wedge. The other three sources, again, deforestation, methane, and fertilizers. Those are the big stories. So we can address some of these emissions, again, by being more efficient. One of the best ways to do this is by reducing food waste around the world. Amazingly, about a third of the food grown in the world is never even eaten. We throw it away. What it's lost sometimes in poorer countries is lost closer to the farmer because sometimes the infrastructure of getting the food from the field to the market breaks down in some countries. In richer countries, though, food waste happens closer to the consumer, in our markets, in homes, and cafeterias where we are kind of throwing food away or not using leftovers the way we should. Another way to reduce the demands on the food system is to eat less meat or more plant-rich diets, because meat production is disproportionately responsible for a lot of greenhouse gas emissions. We're not saying everyone in the world has to be 100% vegan or vegetarian, but especially rich countries where we overconsume meat, we could certainly dial that down, both for the environment, but also our own health. So food waste and shifting diets to be a little bit healthier kinds of diets would be very helpful to reducing these emissions. Also, directly protecting ecosystems, especially forest and peatlands and other areas that are being cleared for agriculture, let's protect them with laws, regulations, and incentives to keep them from being burned down. And then finally, we can grow the food we still grow on the land that already grows it better. And you'll hear a lot about this today. It's called like regenerative agriculture or conservation agriculture. These are methods of growing food that help reduce the emissions of greenhouse gases, and later we'll show you can maybe even absorb some carbon dioxide and put it into the soil or into forest. This bubble diagram here shows us the relative importance of addressing diets and food waste are the biggest solutions. Protecting ecosystems are important, as well as changing the way we farm the food we already grow. All of those things turn out to be very important. I'll move a little more quickly through the remaining solutions. In industry, we have a wide variety of things that have to be addressed, including the production of metals, especially steel, cement, I mentioned before, chemicals, including polymers. Plastics are sometimes thought to be a big climate problem. They're about 1.5%, maybe 1.5% of the climate change problem are related to the production, use, and disposal of plastics. So it definitely adds up, but it's in the 1% to 2% range. Plastics, of course, cause many other environmental problems, so that's going to be a serious issue. And of course, the waste disposal is about 3% of all the waste in the world. It's about 3% of global emissions. So some ways we can help reduce emissions from industry is improve materials we make, like cements, steels, plastics, and so on. We can address refrigerants. I mentioned those before, these chemicals that are disproportionately very important. When we throw away refrigerators and air conditioners and they go to landfills, we have to make sure we recover or destroy the refrigerants inside them so they don't leak into the atmosphere by accident. And we can also learn how to use waste as a resource. Instead of throwing things away, can they be reused, recycled, composted, or turned into energy? And we can look at all sorts of kind of industrial solutions. These are just a few. Our research team is now adding a bunch of new ones as well. And we find there are hundreds of different solutions in the industrial sector we can look at. Transport's really important too. We all want to get around. One of the things that's been so remarkable the 20th and 21st century is the increasing mobility of the human species. And we like that. And people want to travel, they want to go places, but now we have to learn how to do it in a way that doesn't harm the climate. Well, it turns out in transportation, most of the emissions, to first approximation, come from road transportation. Of the 14% of emissions, 10% of that comes from roads, cars, trucks, and so on. Flying gets a lot of attention, but it's actually less than 2% of emissions, but it's still very important. And everything else, mainly ships, trains, other things like this, are the remaining 2%. Again, we see this repeating story of we can take today's system and make it more efficient. We can still have cars that burn petroleum, use gasoline or something, but we can make them more efficient. We can make more efficient trucks and airplanes and ships. But then we can also shift how we transport things to alternatives, more walking, more bicycling, more carpooling, more public transit, more high-speed rail, or what we're doing today right now, telepresence. We all didn't fly somewhere to attend this class. We're doing it electronically, which is far more efficient. And then, of course, we can propel vehicles, especially cars and trains and eventually trucks and perhaps planes, with alternative fuels, especially electricity, especially if electricity is produced renewably. So when we look at these solutions about efficiency, shifting the way we do things, and electrification, we see a lot of different solutions to climate change here. I'll wrap this up in this section with buildings. Buildings emit about 6% directly of greenhouse gases, though they of course drive a lot of the electricity emissions that happen, but those emissions are counted at the power plant, even though the electricity itself is consumed on the grid somewhere else, in a building usually. It turns out the 6% of emissions that come directly from buildings, it's about 2 to 1 residential buildings to commercial buildings. And it's really important to note that while we can build new buildings that are far more efficient than old buildings, in reality, for the next 50 years, most of the buildings we'll see in the next 50 years have already been built. There are hundreds of millions of existing structures that need to be made more efficient and renovated as we're building new buildings as well. But we're not going to tear down everything. We're going to have to work and retrofit hundreds of millions of buildings on Earth today. Again, efficiency is going to be really key. Shifting the energy sources within buildings. And again, we're addressing those pesky refrigerants, not only in the landfills, but in the buildings in which they operate, to make sure they're not leaking within our buildings. A leaking air conditioner, a leaking refrigerator can emit those F gases into the atmosphere, also contributing to climate change. So again, we see a lot of these different kinds of sources of changing efficiency and energy sources here. I know that's a lot I just walked through, but I wanted to show you 5 major areas where we can dramatically reduce greenhouse gas emissions by looking at efficiency and shifting the way we do things. The second big bundle of solutions is around the sinks of carbon, that is, the things in nature that absorb carbon dioxide, mainly forest and in the oceans. And just to reiterate, of all the greenhouse gases emitted, about 24% of them are removed by land, primarily forest ecosystems, and about 17% removed by the oceans, leaving 59% of the greenhouse gases in the atmosphere. On land, again, these are mostly, these sinks of carbon are in forest for the most part, and it's caused by photosynthesis and the accumulation of more of that carbon that is captured during photosynthesis in biomass, or basically trees, and in what we call soil organic matter, the dark, rich kind of humus molecules, the humic acids and things that build up in rich soils. When we have more trees and richer soils, we're taking carbon out of the atmosphere and kind of bringing it back home, back to our forest and back to our soils. To make sure that these carbon sinks are intact, and maybe it could even grow a little bit, first we have to stop clearing forest, and that means stopping the drivers of deforestation, which are largely agriculture. So again, reducing food waste and changing our diets not only makes agriculture a lower emitter, it helps protect forest elsewhere that are not in agriculture today, taking the pressure off of clearing forests down the road. Also, protecting and restoring these forests and other ecosystems are really crucial here. And improving agricultural practices on our existing farms may allow those farms to build up the carbon that we see in soils, not only restoring trees, but also restoring the soils on existing agricultural land. Again, this idea of regenerative agriculture, which could actually sequester and kind of remove additional carbon from the atmosphere. You're going to hear a lot of estimates about how big this is. There's a recent study published by the Rodale Institute, for example. But listen to the scientist here. The scientific community believes that this is very important, but a relatively small part of solving climate change. Some proponents are saying it's much bigger, but the data really isn't very clear on that. We should be saying it's there, but it's probably a lot smaller than some are claiming. And we can also go to the kind of degraded lands that maybe were once used for farms, but are now really kind of beat up and not useful to anyone. Let's see if we can restore those and bring those back to health and maybe be part of the solution to climate change as well as growing more food. So these kind of land-based sinks of carbon can be both kind of in terms of protecting ecosystems, changing the way we farm, and protecting ecosystems altogether. Oceans are also a big part of the carbon removal of nature, and oceans do this three different ways. One is what we call the solubility pump. This is carbon dioxide that just dissolves in seawater naturally. Water absorbs carbon dioxide, it can dissolve, forming carbonic acid. So that's very interesting. The problem is, as water warms up, as the oceans warm, their ability to hold carbon dioxide actually goes down. Most of the time when you warm up water, it dissolves things better, but in the case of CO2, it actually gets worse. So climate change could make the ocean's ability to absorb CO2 diminish somewhat, and that can be a problem. Oceans also absorb carbon through what we call the carbonate pump. That is making things like shells, things made of calcium carbonate. When carbon goes into seawater and it forms a shell or a coral reef, it removes that carbon out of the atmosphere and locks it up kind of permanently in shells and in corals, which is really fantastic. And finally, this thing called the biological pump. This is the plants in the ocean, kind of kelp, phytoplankton, other things that are doing photosynthesis within seawater and absorbing CO2 into the plants, and those plants die and get settled into the bottom of the ocean where they stay for a long period of time. So those three different mechanisms, kind of chemistry, making shells, and making plants, are how the oceans can remove CO2 out of the atmosphere. We humans may be able to help that along a little bit and protect that, but a lot of the oceans are very difficult for us to manage. But we can certainly do things like help restore coastal wetlands and coastal ecosystems, protecting them and restoring them. And those could help absorb some carbon, but also be really good for our coastlines, making them more resilient to storms and be more biodiverse, which would be good anyway. Finally, I haven't mentioned this so far, but there are some promising technologies that could maybe help our forests and our oceans remove carbon out of the atmosphere. And so some technologists, engineers, and so on are building machines that could actually absorb CO2 out of the atmosphere and lock it up in either long-term geologic reservoirs or into new materials or into liquid fuels, things that could be pretty interesting. So the idea is to remove carbon out of the atmosphere with a machine and either store it, maybe underground somewhere, or better yet, we could use it for something. Wouldn't it be great if we could take CO2 out of the air and make jet fuel out of it? So when we fly, we don't emit any CO2. Whatever is emitted by burning it in a plane is removed later and put back into jet fuel. Or let's make plastic out of the air instead out of oil. Leave the oil in the ground. Let's remove carbon out of the atmosphere if we need to make plastics and use it that way. So I like the idea of using kind of the waste of greenhouse gases in the atmosphere as a feedstock for things that our civilization might need, like fuels, materials, and so on. That would be really pretty cool. So I've shown you different solutions to climate change that started by reducing the sources of pollution from the beginning, to work with nature and maybe some technology to remove greenhouse gases in sinks, we call them. But I haven't mentioned this third principle. As it turns out that beyond reducing emissions and working with nature to remove greenhouse gases, there's a third area that's also important. It's basically around improving society as a whole, especially around questions of equity. And one of the things we've noticed is especially promoting access to education and healthcare more equally in the world, especially across gender lines, turns out to have a very powerful effect on climate change. especially as women and girls have more opportunity for education and access to healthcare across the world. We're seeing a dramatic change in population growth, for example. As women and girls are having more access to education and opportunity and economic power, as well as access to healthcare, women are voluntarily just choosing on their own to have fewer children, but healthier children, and often later in life. And this is bending the curve on population growth very, very quickly, in fact. And we're starting to see a dramatic slowdown in the growth of population, which directly doesn't affect emissions, but long-term it will. So by improving society in ways that are good anyway, it shouldn't be done just for climate change, that's for sure, but it has a secondary effect that can be beneficial to climate change too. Also improving the power of indigenous communities around the world. When indigenous communities are protecting their own lands, especially forest, those forests tend to be absorbing more carbon and be more productive and more diverse than forests elsewhere. So again, the things that are kind of promoting justice and equality and equity around the world often go hand in hand with climate solutions, which is really fantastic. So let's put all this together. I know I gave you a lot of different solutions here, kind of a long list of things to work on, but let's summarize it here. If we want to solve climate change, we have to do many different things, but one of the things we have to do is reduce the primary sources of pollution in electricity, in food, in industry, transportation, and buildings are the big areas. I showed you these before, but things like efficiency and changing production electricity, or food waste and diets and food, along with protecting ecosystems and farming differently, and so on. We also looked at ways we can support the sinks of carbon out of the atmosphere, and we found that our activities could help enhance them and protect them on land especially, but perhaps in the oceans and maybe with machines as well. And then we found that more fundamental changes to society that were never intended as a climate solution, like health and education parity around the world, also can contribute to climate change solutions. Again, each of these circles represents a suite of solutions. There are hundreds of things inside each of those, but the size of that circle represents the size of the climate change solutions that might be available there. And if we put all of those things together, we have an incredible suite of opportunities to address climate change and get to drawdown. So we actually took all of those potential solutions and we asked the question, what if? What if we did all of them? Could we stop climate change, and then how quickly? So these are computer models showing what would happen if we did nothing more. The red curve shows here we are today, and here's if we keep going in the path we're currently on. That's what would happen to the levels of greenhouse gases in the atmosphere. But we don't have to stay the way we are. We could start to have more action on climate change and get to this yellow curve. Or we could get even more aggressive and get to this green curve, showing 2 or 3 different scenarios of the future. One is business as usual, if you will. The second one was kind of moderate levels of action. And the third one in scenario 2 is very aggressive moments of action. If we do that, we can stop climate change as early as the 2040s. That's incredibly aggressive. Or perhaps through the 2050s into the early 2060s. All of those things seem to be possible with technologies we have today in ways that would actually make money and be possible right now. And if we did that, the world is already about 1 degree warmer than it should be. We can stop climate change before it gets to about 1.5 degrees warmer is still possible, or perhaps 2 degrees warmer. But if we do nothing more, we're going to be heading towards about 3 degrees warmer by the end of the century, and that's really, really bad. The good news here is we do have enough solutions to do the job. We have about 100 solutions that exist right now without inventing any new technology. And if we add new technologies, it would just make it even easier. So this is great. We have the solutions we need and we're getting more. But we also have to know, what will it cost? It turns out this will actually save us a lot of money. Yes, initially the cost of addressing climate change, this graph shows the cost in the vertical axis and the size of the solutions in the horizontal axis. Initially, we do have to pay a little bit of money for some of these solutions. Some of them we don't. On the far left, we actually make money immediately because they use maybe efficiency to cut down our use of energy or stopping food waste. But as we go through the next few decades, we add the initial cost, but also all the lifetime savings and maybe new revenues. We find that actually climate change saves us a lot of money. We could spend 20 to 30 trillion dollars today, but save and make between 90 and 125 trillion dollars over the next couple of decades. A huge return on investment. And that doesn't even count the damages to the world that we avoid by stopping climate change. All of the terrible things that might happen if we don't do this aren't even in this equation. So this is the biggest business opportunity in human history right now. So if people tell you we can't afford to address climate change, they're lying to you, or they're in a special interest that is one of the few that would benefit from continuing to destroy the planet, perhaps the fossil fuel industry. So what have we learned? We've learned, first of all, it is not too late to address climate change. We should have done it 30 years ago. We didn't, but here we are now, and we can still get on board and stop it from getting a lot worse. So we can address drawdown, we can stop climate change with things we have today. We can use new solutions. We can wait for new technologies to come along, but that's a bad idea. We have the solutions we need now, and what we don't have is time. I'd rather have time than tech. We like to say in drawdown, now is better than new. So let's put what we have out into practice today. And along the way, maybe other things will come along to make it easier, cheaper, faster, wonderful, but don't stop. We've already wasted 30 to 40 years. What we really need to do is get started today. Now, to make these things happen, the solutions I showed you don't happen by magic. They have to happen and get into the world because of our actions and our intentions. We call these things accelerators. These are the things that humans can do to make those solutions more likely to happen and grow in scale. First, we're going to change the rules, like policies, laws, the regulations, taxes, incentives, kind of how governments regulate us, and the rules that we follow around the world. That would help a lot. We also have to shift capital. Trillions of dollars have to get out of bad things like fossil fuels and destructive agriculture and instead shift to good things like renewable energy and regenerative agriculture. So that's going to be the financial firms of the world, government funds, our own money, and so on, as well as philanthropy. We need to change the rules of business so businesses are actually accountable to environmental outcomes that they affect, not just short-term profits. That's beginning to happen, but not quickly enough. We need more here. More technology is also very helpful. Technologies that can come along later and complement what we already do, but not make us wait for technologies. We should never stop and wait for somebody. Let's get started, but if they can come alongside us and fold in their technologies with the technologies we have now, that'd be great. And then we individuals have to change our own behavior sometimes. A lot of these solutions do include a behavioral element like food waste, diets, energy efficiency. Those not just depend on the government solving the problems, it depends on us contributing something too. And the real solutions are going to require all 5 of these things: policy, capital, business, technology, and behavior. We need them all. And we need to work together over the next few decades. This isn't going to be solved in a year. It may take a few decades to do this, but we can do it in different waves. For example, right now, we can deploy today technologies that already make us money, that are obvious quick wins that are very, very helpful, like energy efficiency. Why are we doing more of that now? We should have been doing it for decades. Reducing food waste. This is probably Earth's dumbest problem, that we throw away 1/3 of the food that we grow on the planet. Can we solve some of that? That would take a lot of pressure off climate change, but also deforestation, biodiversity, and so on. Huge opportunities there. We can reduce the leaks of methane in the natural gas infrastructure before we phase out natural gas altogether. Can we at least plug the leaks from fracking, from gas pipelines, and so on? That could happen right now and actually save money for the natural gas industry. We can switch to renewable energy. 10 years ago, I wouldn't have said this, but right now, switching to renewables makes you money because renewables are now the cheapest form of electricity on Earth today. This is the cost of producing 1 megawatt hour of electricity on the world today. And we see utility scale, large scale solar panels and wind are cheaper than gas, coal, nuclear, and especially peaking gas plants. And so if you were building electricity production today, you would have to economically start with solar and wind. That's the only way to go. Then the next wave of activity, after the kind of quick wins we do in the 2020s, are going to be things that we start today, but might take a little bit longer. That is long-term infrastructure change, like changing the way we farm. About 40% of all of Earth's land surface is in some form of agriculture. We're going to have to change every farm and every ranch on the planet. That's going to take a while, maybe 20, 30 years to finish the job. We also have to change buildings and remove all of the existing heating and cooling equipment, water heating equipment, refrigeration equipment. All of that needs to be torn out and retrofitted. Buildings also need to be made more efficient and retrofitted for building envelopes and smarter glass and building automation systems. And there's hundreds and hundreds of millions of existing buildings. This is going to keep us very busy for a long time. We also have to change transportation infrastructure, like every road, every vehicle, every train, every rail, every boat, every airplane will have to change as well. And this is going to take some deep time to pull that off and trillions of dollars, but we're going to make money and save money along the way. Finally, the last wave of kind of activity, I think, might be starting today, but could pay off maybe decades from now in the 2030s and 2040s. Technologies that could come in and fold into the things we already are doing and make them even better. For example, new ways of making cement. We're going to need ways of doing that. New kinds of refrigerants, new ways of making steel. I'm very interested in how can we make jet fuels that don't harm climate change, that are carbon neutral, or plastics that are made from biological materials or the waste in the atmosphere itself. How can we do that instead of using petroleum to make polymers and plastics? So when I look at the climate change problem, I see a big problem, of course, but I also see an incredible opportunity here for the economy, for equity, for justice, for communities, for all the things we care about. We get to, not only do we have to, we get to reimagine the world. This is, again, the biggest opportunity in human history for business, the economy, for equity, for justice, communities, everything. We get to rebuild it all, and we get to do it better. But in order to do that, we don't need just technologies and science and policy and business, all of that. We definitely need all of that. But I think we need something more. We also need a better form of bold leadership and vision to build a better world. Unfortunately today, I'm coming from a United States perspective right now, which is especially depressing, but we have leadership in the world today that isn't about articulating a good future and bringing people together to build a better future. It's about pointing to a disastrous future and tearing us apart about who's to blame for it. That's not leadership, that's bullying. That's a very different thing. A real leader, for example, like Martin Luther King or Nelson Mandela, they showed us a vision of a better world, maybe a challenging world that was, bothered some people, but we all knew in our bones it was a better world and invited all of us to collaborate in building a better world. Martin Luther King didn't go around America saying, I have a nightmare. He talked about a dream he had about a better world where everyone was judged on their character, not the color of their skin. We're still working on his dream. He died for his dream and we're far from achieving it, but we know it's the right course and we know we can pull together and solve problems is the only way to make changes that we need. So that's what we need on climate change too, an invitation to join together, all of us working together, collaborating to build better futures for us and our children. And that's, I believe, how we're going to get there. So I'm going to wrap up now and we'll shift to some question and answer and discussion in a second. But I want to also have the opportunity here to ask something of you. You're all young people in the height of your lives, getting this wonderful education, engaging with Enactus, thinking about things you can do to make the world better around you. So I want to ask you to keep doing that, to keep engaging, to keep learning and sharing what you know with others. It's so critical that you keep doing that and make yourself a resource to the world and to those around you. I hope that we can be helpful to you. Please use us as a resource anytime you want. We're there to serve you and others. So go to drawdown.org and follow us on social media at Project Drawdown. But most of all, I want you to remember something, that the future is not yet determined. The future is still, in fact, up for grabs, and it's going to belong to you. If you will take the risk, and if you accept the responsibility of consciously creating a future that you want, if you do that, the future is yours to write, and I hope you will. So with that, I'll stop here and maybe we'll take some questions and answers. I believe Elizabeth will moderate that in the Q&A section of the Zoom chat site. So please type in your questions in the Q&A section and she'll then go through those and we'll see if we can work through those together. So thank you very, very much. And let me stop sharing the screen here and see if we can get that to work right there.
Oh, thanks so much, John. Thanks so much. We really appreciate you sharing your expertise with us today. And thanks everybody for attending the webinar for the Race for Climate Action. John and I are with Project Drawdown. We have representatives from Enactus here, as well as Intuit, the major sponsor for the Race for Climate Action. As John mentioned, we would love to fill up that Q&A box. As a quick note, we hope you all do want to participate in the Race for Climate Action. And on Enactus Plus, there's a discussion board where you can put questions as well. But that's going to be I'll be looking at that, and that's a few steps removed from John himself. So if you have questions that you'd like to ask today, please go ahead and type those in the Q&A. We've got a couple already, John, and I want to start with a question about clean cook stoves. So one team is working on a clean cook stove solution, and they're wondering how much does open fire cooking contribute to emissions? And they also are considering using trees as fuel.
Yeah, cook stoves are a very, very important issue around climate change, but also air quality and human health. When you burn fuels like they're used in cook stoves today in much of the world, we're seeing not only is the CO2 emissions, that's part of the issue, but they also produce through incomplete combustion what are called kind of black carbon or kind of particulate matter that's released into the atmosphere as well. I didn't mention that, but what's called black carbon, basically kind of soot, is also a warming agent in the atmosphere. Some particles in the atmosphere cool the atmosphere, but these ones, the soot and the kind of black carbon, actually warm the atmosphere. I didn't mention those along the other greenhouse gases, perhaps I should have. So this idea has been around for a long time, that if we could clean up the cook stoves that are seen in much of the developing world, we could actually improve contributions to climate change, but also indoor air quality. When you're burning like dung or straw or wood fuels in an open fire pit in a home without proper ventilation, you create enormous air quality burdens that are actually affecting the health of billions of people around the world today. So if we could remove that problem from a human health point of view, air quality point of view, and a climate point of view, it's an enormous win. The challenge has been not the technology so much. There have been a lot of very clean cook stoves where the combustion's more complete, more effective, uses different kinds of fuels, things like this. People have proposed these and built them many, many times, but they've yet to have really widespread adoption, and that's something you really want to take a look at. There's a group called JPAL, J-P-A-L, that you can look at. It's called the Poverty Action Lab. It's based at MIT in the United States, but also works across the world. They've actually done an analysis of why clean cook stoves have not yet really been implemented at scale. And so it's not just a technological and engineering issue, of course that is important, but it's also kind of a social issue of like, why are these cook stoves not being used as much as we thought they would? They seem like they'd be a great idea, but what are the barriers for implementation and scaling? Also, I think the Gates Foundation, Bill and Melinda Gates Foundation has been thinking about this, as have various UN agencies. So if you've been thinking about cook stoves, great, really important problem, but make sure you look at the research that's showing not just the engineering solutions, but what are the social barriers to implementation? Why are people not using them as much as we'd hoped would happen? How do we get this to actually get deployed in the world? That's gonna be very crucial as well. But great, great area to focus on. Fantastic.
Thanks for that. Thanks for the question, and thank you so much for the answer, John. We have another question where their team is planning to conduct a survey to collect data for logistics in agriculture, so really understanding the agricultural sector. And that team is wondering if there are any good references for them to use as they construct their survey.
I probably have to know a little bit more about that. So maybe we can follow up with that on if I can ask the question of the questioner, if you will. Maybe to say what kinds of farmers, what part of the world, and what questions are you asking? Are you looking at like how they farm, or are you looking at questions about food waste, for example, about why farmers aren't getting the product to market? So it very much depends on the context, I think, of what you're asking about. So maybe we could circle back to that question in a minute. If you could add a few more details to that, I could maybe be more helpful. That's a really good question, but it's a big question. So I'd like to know a bit more where you're aiming at.
Perfect. Yeah. So if we can get a little more detail, that would be fabulous. Thanks for that, John. We've got another question, and this one is a pretty great softball because John and I are working on it at this moment, but there's a question about whether or not we have some teaching modules for, let's say, students on climate change and Project Drawdown, because they'd like to really develop some teaching tools to educate on these issues for a number of their constituencies.
Oh, funny you should ask that. Yeah, in about a week and a half, Elizabeth and I have been working on this for a long time. We're going to start filming actually kind of a more in-depth version of the kind of material I showed you today. So it's ironically going to be more in-depth and longer, but we're going to cut it up into lots of little pieces. So it's actually shorter little nuggets that people can watch in short stints on the phone, on an iPad, on a computer, whatever they are watching things on. And so it's going to be about 15 to 20 modules of some kind of lecture type things for maybe 10 to 15 minutes at a time, but also interviewing experts on climate solutions from around the world from different backgrounds. So it's not just one person's perspective or one organization's perspective. You're going to see a lot of different kinds of views on this as well. And we're making that free, available, and actually I'd like to thank Intuit as one of the sponsors who's helping us make that possible. And we actually will be very happy to share all of that with Enactus as well, which is one of the original goals. And so we're going to be doing kind of live courses like this, but we'll make sure that this even more in-depth, be about 2 to 3 hours of content altogether. And its intended audience is like folks like you. It's going to be college students, maybe graduate students, people going back to school for their MBA, who knows, but also people who are beginning a new job. Let's say you're working for a company and you've never worked on climate change before, but your boss says, hey, you're the climate change expert now for our company, make us better on climate change. Where do you start? Where do you even begin to learn about this? We hope we can help be a resource for that, but also for like policymakers, maybe a new staffer in a legislative body is suddenly has to learn about climate change. It turns out there's really not a lot of great resources to learn about climate solutions. There's a lot of resources to learn about the climate challenges, but on the solution side, we felt there was a bit of a gap. And so we're trying to fill that at the kind of university to graduate to professional space. And it should be available, I would guess, the end of this year, beginning of 2021. And keep looking at drawdown.org and follow us on social media, or sign up for our newsletter if you like, and you'll certainly find out about it. But I'm sure that our friends at Enactus and through Intuit will also help spread the word as well. So just stay engaged, and it'll be literally filmed in about 2 weeks from today. And but it'll take some time to post-produce it and edit it into a really seamless kind of useful set of tools. So stay tuned. And Elizabeth will also be working on educational modules that are intended for younger audiences. We have kind of a youth track as well. They'll be developing, working with kind of YouTube science stars, if you will, who help communicate science topics to young people in very engaging ways. That's going to be very, very exciting. And we also want to have kind of educational resources for kind of just broader general audiences. But we decided that rather than being kind of more informational like this is, to be more story-based, to kind of tell a story that highlights climate solutions, but through the power of the narrative of kind of walking alongside a heroine, a hero who's on a journey of climate action and following them through their journey and showing what could happen. That'll probably be happening in 2021. We're now just hiring kind of a new storyteller kind of position at Project Drawdown to help us with that. So yeah, stay tuned, but we'll have 3 or 4 different offerings for youth, for general audiences, and then this university to professional audience is what we'll be starting with most.
Great. Yeah, thanks so much, John. And thanks for that question, because that teed us up just perfectly to talk about this really fabulous collaboration we have with Intuit and with Enactus and with all of you now as part of the Race for Climate Action. So John, and actually Enactus team, this is a question kind of for multiple folks. So John, I'd like you to address the process of planting trees in terms of the in terms of being a sink, a carbon sink. And then when John's done, the add-on to that is, would a tree planting project be something that would be accepted by the Race for Climate Action competition? So that's a question where, I'd love for the Enactus folks to jump in. So John, can you talk a little bit about tree planting, please?
Yeah, well, tree planting is a great idea. It would be very helpful for climate change for sure. But remember the difference between sources and sinks when it comes to greenhouse gases. And again, that bathtub metaphor might be helpful here. If your bathtub's overflowing, causing damage, turning off the faucet, the sources of pollution from the beginning, really is the only long-term permanent solution. You have to turn those sources down to zero. The trees are kind of like the mop. They're helping to clean up the emissions we've already made. So that's really important. So planting trees is important. Keeping trees from being burned in the first place is probably more important, but they're both needed. So I love, more trees are good. Keeping trees from burning and getting cut down in the first place is maybe where I'd begin in some ways, but we can be planting trees alongside them. Let's just make sure we do both. The one problem though with planting trees is we can plant them today, but you're gonna have to think about how those trees will be preserved in the future. How do we know if we plant a tree today that someone doesn't burn it down 10 years from now, 20 years from now, 30 years from now, and all of the carbon that was removed and put into that tree could be put right back into the atmosphere? How do we ensure that that land that's planted in trees will continue to be a forest forever? Because that's what we need, is we need to lock that carbon up. Otherwise, it doesn't do that much good. So that's going to be the challenging part. Planting the tree is one thing. It's keeping it planted is the other. Same thing with soils. Other people might be interested in how farms can be managed through what we call regenerative agriculture to put carbon not just into trees, but into the soil. Same problem. How do we guarantee that that soil won't be disturbed in the future? We can farm well today, but maybe that farmer will die or will retire, and somebody else will come in and farm that land and do it in a bad way, and all that carbon's liquidated back to the atmosphere. So I love planting trees and sequestering carbon in soils. Really good. I think that's a great idea, but Enactus should chime in. But I just want to caution that it's not just planting the tree, it needs to keep the trees too. Otherwise, from a climate point of view, it's not as effective as it could have been. But let's see what else other people have to say.
Well, thanks, John. This is Emily Gray with Enactus. I thought I'd hop in for the last part of that question about if a tree planting project would be a good Race for Climate Action entry. And very much with what John said, it really depends on the project itself. And if you have that plan for the long term, if you're able to really measure the kind of impact those trees would have on climate change, there are several factors that would go into making that, a long-term successful project. So definitely don't hesitate to reach out to us at Enactus if you have further questions about the kind of project you have or are planning. races@enactus.org is a great email address for us. So thanks.
Thank you so much, John and Emily. So, just another plug to really check out the incredible and incredibly thoughtful criteria for the Race for Climate Action and find out whether or not your idea is a great fit. We would love to have you all join. We'd love to have all of you all around the world at all levels of agency putting climate solutions into action. Thank you for being part of the solution, everybody. We have time for about one more question, and we have a number in the Q&A. Thank you so much, everybody, for really leaning in and asking these questions. If your question doesn't get answered today, feel free to move it to the Enactus Plus platform, and I'll work on answering them there. So I'm sorry we're not going to be able to answer all of them, but we'll do our best to at least get through one more today. So there's a question, John, about reducing food waste. So one of the teams really wants to work on reducing food waste, and I would love to hear about kind of your experience around that solution. I know you've worked on that a lot, and really giving that team some insights about ways to reduce food waste, especially on the farmer side of the food waste equation.
Well, food waste, again, is like one of the kind of dumbest problems the planet has in some ways, especially the consumer food waste. The side of food waste where it's like the wealthier countries of the world using too much food and being kind of wasteful mindsets about it and throwing food away. that's such an obvious thing that we should fix. And there are great actions for this. The question is often, how do you scale this? How do you get, like, just not you and I making, taking action at home, but scaling it to, thousands and hundreds of thousands, millions of people? That's going to be very challenging. But I'm really glad to hear that you're thinking about focusing on the kind of the other side of the food supply chain, from the farmer getting to the market, because that's kind of a double tragedy. Not only is food lost because perhaps transportation infrastructure broke down and the farmer couldn't get things to the market in time. Maybe the truck or the train didn't arrive in time, or there's a misconnection, an opportunity, or perhaps storage facilities were not adequate and food was left to rot, or labor wasn't available to get to the farm at time of harvest and things were left in the field, perhaps due to other infrastructure or other challenges. So that's going to be very challenging to think about. I guess, some of the solutions are going to require, billions of dollars of improved infrastructure in terms of transport, food storage, labor, things like this. Those are really big, deep infrastructure investments. But there may be, I'm just thinking out loud here, there may be ways of using like technologies that can kind of leapfrog over some of those traditional infrastructure investments. For example, how can a smartphone or something tell farmers like when and where trucks are going by to get their food to market? How do you kind of create a clearinghouse to get growers connected to vehicles that can transport their product to the market? How does the farmer know what the price is in the capital city versus their own community so that they get treated fairly and are paid fairly for their farm products? How do you kind of create, more of a kind of an electronic marketplace that connects the grower to the eventual consumer and circumvents some of the infrastructure challenges we've had before? That could be very interesting. So I guess I would encourage, thinking about the kind of the big built infrastructure, but also the perhaps electronic kind of matchmaking services that could be happening, with different kinds of vehicles, connecting transport to growers, to consumers, things like this. That could be very interesting as well. But I'd have to think more about that, but I would encourage some creative thinking in those spaces. But I'm really glad to see people thinking about not just the consumer end of food waste, which we all are part of probably, but then the farmer end as well, like how to help reduce that loss of food. Again, because that's really a double tragedy. It's not only the loss of food, it's the loss of income and livelihoods to the farmers. And so that's even probably worse than losing the food in some ways. So I'm very heartened to hear that people are working on that.
Thanks, John. And I'm going to mention one, an organization or a group that John worked with when he was at the University of Minnesota and the Institute on the Environment. There's a really fabulous body of research for those of you who are interested specifically in food. And the website is Food Matters. And Food Matters has these fabulously researched interactive articles that really dive into different aspects of not only food waste, but climate and food. So for those of you who are interested in working on food, I highly recommend, and I'll put that in the chat in just a minute, Food Matters as a fabulous resource. With that, John, do you have anything else you want to mention? We're going to hand it over to Emily in just a minute, but anything else that you want to mention to the potential participants of the Race for Climate Action?
Well, I guess I'll just wrap up by saying thank you for thinking of investing your time and energy and creativity into climate solutions. The world needs more creative thinking here. I hope that this presentation gave you kind of a quick crash course on some of the things you need to think about around climate solutions. First lesson of climate solutions is there's not one first lesson of climate solutions. There are so many things we have to learn and do. There's no one solution. There are many solutions and they all have to happen. So we need diverse teams of diverse thinkers thinking in diverse ways, working together to address these problems. So I'm really heartened to see you all take part of this. That's fantastic. Second is we don't have to wait for new technologies. Again, the driving force here is time. The sooner we begin, the easier the problem is. The longer we wait, the harder it is. There's an old quote about going back to tree planting that I like to think about with climate change. Somebody asked, when's the best time to plant a tree? The answer is 50 years ago. What's the second best time to plant a tree? Today. So we missed an opportunity to really address climate change maybe in the 1980s and 1990s when the world was first really learning about this in a big way. We waited too long. We've done a little bit, but not nearly enough to address climate change. So we have to get busy now. So I'd encourage you to think about existing technologies, not inventing new ones necessarily, but how can we quickly scale up what we already know how to do so that it makes a difference in the real world. Things in a blackboard are great, but we'll need those. So I'm not saying don't do that, but we also need to think about very quickly how to bring things to scale instantly, because that's the most important factor with climate change is time, not technology. And it turns out our analysis shows we do have enough even with today's technology. So please focus on fast scaling and diverse thinking would be the things I would really encourage people to look at as we address this challenge. And also to avoid finally the trap of thinking there's ever one solution to a wicked problem. There isn't. There's not one solution to the pandemic. There's not one solution to climate change. There's not one solution to economic justice. We need many. And so please be thinking in diverse ways, bring it all together. And I'll be really excited to see what you come up with. We're going to need a lot of creative thinking. And I can't think of a group better suited to do it than you all. So thanks so much for your time. And I can't wait to see what you do with this.
Oh, thank you so much, John. You all, what a fabulous opportunity to launch you into the projects that you'll be working on that will really put climate solutions into action all around the world. A few last minute housekeeping items that I want to mention for you all. As we talked about in the Q&A, there will be a master class coming soon. John's recording it in a week and a half. So those modules, similar to what you saw today, but really leveled up, will be available in late 2020, early 2021. And so those will be available through the Enactus platform. So make sure you're registered and logged in, and those will be shared with you when they're ready. I also want to let you know that Emily, who is our fantastic Emily and Sheila from Enactus will be following up with all of you who registered and who attended today, making sure that you have the link to the Enactus Plus discussion page. That's the page that I check pretty frequently for questions. So there is a real human on the other side of that. So if you have a question that you didn't have a chance to ask today, feel free to pop it there, and we'll follow up with that link. We also will follow up with a recording of this webinar so that you can refer back to it when you've really figured out what you want your project to be. You can go back and you can listen to John in that particular section. Let's say that you really want to focus on food waste. Go back and dive into that so that you really know, the latest and greatest information about climate solutions related to whatever your project's going to be. So with that, we are so grateful that you all attended today, and we look forward to seeing your projects in action around the world, really moving us all towards that moment in time drawdown. Thanks so much, everyone, and have a fabulous day. Take care.